Hi, good morning, everybody. Today we're going to do section 2 of chapter 3, quadratic equations, functions, and zeros. If we have time, we'll also do section 3, which are analyzing graphs. All right, so in this section, we're going to discuss what quadratic equations are. We're going to use a method of complete the square, and that's going to lead us to the quadratic formula, and we'll discuss discriminants, and then we'll talk about the concepts of zeros using two principles, the principle of zero product and the principle of radicals on how to solve quadratic equations. All right, so first off, we said last time we have the standard form of a quadratic equation is f of x equals ax squared plus bx plus c. And we'll call this one the vertex form. Vertex form. Ax minus h squared plus k. And I'll show you how we get to that in a minute, where it's derived from. Quadratic equations look like this. Because they're equations, they have to be equal to something. So and always, whenever we solve these, we have all the terms on one side set equal to 0. A quadratic function looks like this. F of x, or whatever name you want to give it. So all depends on what we're saying. So if we're saying quadratic equations, then we use that. If quadratic function, then we talk about that. So to solve a quadratic equation, we have 3 methods. The first method is called factoring. The second method is called complete the square. And the third method is the quadratic formula. And the reason I have to do this is because they also grow in ease of use. Factoring only works if it's factorable. If the equation has a factor. In other words, it could be broken up into smaller pieces. Complete the square works all the time, but works best if your middle term, if your b term is even. It's an integer. Because if not, if b is an odd number or a fraction, or odd number and a fraction, then it makes it much more difficult. And the quadratic formula always works. It's a formula, so you just plug and play. But we have to know how all 3 of these work anyway. So let's go and start. If factoring breaks the equation into simpler linear parts. Remember, the quadratic equation is quadratic because the power is 2. That's what makes it a quadratic equation. Which means if I factor out x squared, I get x times x. These are linear because the power is 1. So a quadratic equation is made up of 2 linear equations. And that's what the whole purpose of this is going to be. So the easiest way to look at these, let's start with the answer and work backwards. I'm going to give you 2 linear equations, 2 binomials. These are called binomials because they have 2 terms. We have 2 binomials. And I'm going to use the same numbers, but the only thing I'm going to change is the sign or signs between them. We have x plus 2, x and 2, x and 3, plus plus, plus minus, minus plus, minus minus. So only 4 possibilities we have here. If we multiply these together, what that means is everything in this first parenthesis has to multiply to everything in the second. And the way we check it is, since we have 2 terms here and we have 2 terms here, when we first multiply them, we should have 4 terms. All right. So let's look at that. We have x times x is x squared. X times 3, the positive times positive is positive. X times 3 is 3x. That does it for the x. Positive times positive is positive. So positive times positive is positive. 2 times x is 2x. Positive times positive is positive. 2 times 3 is 6. So there are 4 terms. We have 2 terms times 2 terms gives us 4 terms. The rule of thumb is always, whenever you get rid of parentheses, always, your next step is always to combine like terms. Whenever you get rid of parentheses, next step should be always to combine like terms. 3x plus 2x are both positive. So we have the x squared. So we have 3 plus 2 is 5, and they're all x's. And then plus 6. Do the same thing with the next one. X times x, x squared. Positive times negative is negative. X times 3 is 3x. Positive times positive is positive. 2 times x is 2x. Positive times negative is negative. 2 times 3 is 6. Again, we have 4 terms, 2 times 2. We got rid of parentheses, combine like terms. 3 is bigger than 2. 3 is negative, so the answer is negative. 3 minus 2 is 1. 1x minus x times x is x squared. Positive times positive is positive. X times 3 is 3x. Negative times positive is negative. 2 times x is 2x. Negative times positive is negative. 2 times 3 is 6. Again, combine like terms. 3 is bigger than 2 and it's positive. 3 minus 2 is 1. X minus 6. And the last one. X times x is x squared. Positive times negative is negative. X times 3 is 3x. Negative times positive is negative. 2 times x is 2x. Negative times negative is positive. 2 times 3 is 6. Combine like terms. X squared comes down. They're both negative, so we add them. 3 plus 2 is 5. And then bring down the 6. So that's foiling, distributing actually. Foiling only works when you have binomials, but we'll have bigger equations. So whenever you multiply two equations together, you're really distributing. Everything from the first parenthesis has to multiply to everything in the second. Everything in the first to the second. Now, what we're interested in is going backwards. That's called factoring. We go from a quadratic equation. We want to break it down into its component linear equations. So let's look at this pattern here. In the first one, we had x squared plus 5x plus 6. Next one, we had x squared plus 1x minus 6. X squared minus 1x minus 6. And then x squared minus 5x plus 6. I'm going to give you the steps here. First step, we want to fill in the first parts. What two numbers or terms multiply to give you x squared? Well, we know that x squared is made up of x times x. So we put x's in here. Second step. Look at the second sign. Look at the second sign. That's this one. This one is the second sign. If it is positive, then both signs inside the parentheses will be the same. They will be the first sign. So if the second sign's a plus, then both signs are the same. That goes inside the parentheses. They'll be the same, and they're going to be whatever the first sign is. Since that's a plus, both of the signs are going to be the same. They're going to be, in this case, they're both going to be plus. Now comes the hard part. Look at the third term. The last number, the constant. Oops, I forgot the B. Oh. Hold on. I'd finish this one. If the second sign is a plus, they're both the same. So we'll come back to this in a little bit. If it is a negative, the second sign is negative, then the signs are opposite. One's going to be positive and one's going to be negative. The larger number of the answer will have the first sign. So if the second sign is a minus, then they're going to have opposite signs inside the parentheses. But the larger number, that when you finish all the stuff, the final answer, the larger number will have whatever the first sign is. I'll show you what that means in a minute. Let's go back to this one. Now we got to figure out what numbers are. Look at the third term. The last number. What two numbers multiplied together equal the third term? When you add or subtract whatever the second sign is, whether either you add or subtract, when you add or subtract the two numbers, you get the middle number. So after we look at the first one, we look at what makes up the first term. X times x is x squared. Then we look at the second sign. If the second sign's a plus, that means both signs are the same. They're whatever the first sign is. If they're minus, then they're opposites. One's a plus, one's a minus. And the bigger number of this last part gets the first sign. The last term, what two numbers multiply give us that third term? When we add or subtract them, we get the middle term. Let's see what all this stuff means. So, second sign's a plus, so they're the same. They're both plus in this case. What times what equals 6? So that's plus. When we add them, because that's a plus, we get 5. 2 times 3 is 6. 2 plus 3 is 5. So those are our answers. Those are our factors. All right, let's look at the next one. Same stuff. First step, look at the first term. What makes up x squared? That goes in the first spaces. X times X equals X squared. Second step, look at the second sign. It's a minus. That means one's a positive and one's a negative. The bigger answer will be the positive number. Third step, look at the last number. What two numbers multiplied equals 6? That when I subtract them, I get 1. 3 times 2, 3 minus 2. Since the first sign's a plus, the bigger number 3 gets the plus. First term, what makes up X squared? X times X. The second sign, it's a minus, so they're opposite signs. In this case, the bigger number will be negative. What times what equals 6? When I subtract them, I get 1. 3 times 2. 3 times 2. 3 minus 2 is 1. But the bigger number gets the minus. What makes up the first term? Look at the second sign. It's a plus, so they're both the same. It's whatever that is, so they're both minus. What times what equals 6? When I add them, it equals 5. 3 times 2, 3 plus 2. So since they're both the same signs, it doesn't matter where I put them. So that's the factoring technique. And those are the steps. Okay, this method here, remember, our quadratic equations in standard form look like this. This only works when A is equal, the leading coefficient is equal to 1. That's when you use this stuff. So here's an example. Remember, it's a quadratic equation, so it has to be everything on one side set equals 0. Now go ahead and factor this one out. Because now, since it's equal to 0, we are solving this. We're going to find the values of X that make this a true statement. We're not done until X equals 2 numbers. That's what the X squared stands for. Let's see. X squared is made up of X times X. The second sign's a minus, so that means the signs are opposites. The bigger answer will be negative, so the bigger number goes here. What two numbers multiplied together give you 15? So it's a minus, that when you subtract them, you get 2. Five times 3 is 15. 5 minus 2 or 5 minus 3 is 2. So those are the two numbers. Since the first sign's a minus, the 5 goes with the minus. Okay, we've just factored it. That's the first step. Now, to solve, we take both of these individual monomials and set them equal to 0. And solve. So x is equal to -3, because we subtract 3 from both sides. And we add 5 to both sides. So x is equal to 5. Those are my solutions. Remember, these are solutions. These are also our x-intercepts. Remember in chapter 1, when we discussed x-intercepts. The way you find x-intercept is your first step. Set y equal to 0. And solve for x. And that's what we did. We set the equation equal to 0. This is what y is. And we got the x value. So it's -3, 0, 5, 0. Those are the x-intercept locations. And these are the solutions, which are the x values. So we need to have those to also to graph the equation. We need to have the x-intercepts. So if we graph this thing, we know we have a x-intercept at -3 and an x-intercept at 5. And we also know that we have a y-intercept. The y-intercept is always the constant. The y-intercept is going to be at -15. Because that was the constant of our original equation. All right, so let's look at if a doesn't equal 1. Remember, the above examples were when a equals 1. These were when a equals 1. But now, if it's not equal to 1, let's say we had 6x squared minus x minus 12. Set it equal to 0. And here are those steps. Steps if a does not equal 1. First step. Place the first term without the exponents into the first spaces in the parentheses. So we're taking x squared. That's made up of 6x and 6x. Do the second sign step like we did before. As before. So if it's negative, that means the signs are opposite. One's plus, one's minus. And the bigger answer, the bigger number goes there when we finish our solutions, since that's a minus. Third step. Multiply the A times the C terms. Or just the absolute values. We don't need signs. Only the numbers. So remember, A x squared plus bx plus c equals 0. So the A term is 6 and the C term is negative 12, but we're just going to multiply 6 times 12. That equals 72. Find the two numbers as before. So what times what equals 72? That when we subtract them, since that's a minus sign, we equal 1. Because our B term is equal to 1, it equals 1. So this is where it gets tough. So what we have to do here is let's look at what two numbers we have. 1 times 72 equals 72. 2 times 36 is 72. 3 times 24 equals 72. Four times 18 equals 72. 5, 6. 6 times 12 equals 72. 8 times 9 equals 72. Look for all possible combinations. We're looking for two numbers that when we subtract them, it equals 1. 72 minus 1 is not 1. 36 minus 2, that's too big. 24 minus 3, no. 18 minus 4 is 14. 12 minus 6 is 6. 9 minus 8 is 1. So these are the numbers. Because when we subtract them, we get 1. So the numbers are 9 times 8. 9 minus 8. Since the first sign's a minus, remember they're opposite signs because the second sign's a minus. The first sign's a minus. That means the bigger number goes there. And the smaller number goes the other one. All right, so now what we have is 6x plus 8 times 6x minus 9 equals 0. We're not done yet. Factor common terms out of both parentheses. So what do 6 and 8 have in common? Well, what is 6 made up of? 2 times 3, right? 8 is made up of 2 times 4. So they both have a 2 in common. So I take out the 2. To see what goes inside the parentheses, I divide both of these numbers by 2, since I took it out. 6 divided by 2 is 3x. 8 divided by 2 is 4. Same thing with the second one. What makes up 6? 2 times 3. What makes up 9? 3 times 3. So I can take out a 3. So 6 divided by 3 and 9 divided by 3. 6 divided by 3 is 2x minus 9 divided by 3 is 3. Erase what you took out. Just get rid of them. And then solve both parentheses set equal to 0. Three x plus 4 equals 0. 2x minus 3 equals 0. We subtract 4 and divide by 3, so x is equal to negative 4/3. X is equal to, move the 3 over, divide by 2, 3 over 2. So these are our two x-intercepts. By this time, you should be able to solve for x. So that's why I'm not wasting my time doing that. Out of room. So that's how, if you have a leading coefficient in front of your terms, that's how it works. You want to try another one? Okay, let me put another one together. So we have 12x squared plus 13x plus 3 equals 0. What's the first step? Yeah, put the 12x in both of them. Very good. Next step. Look at the second sign. If it's a plus, what does that tell us? They're both the same. they're both whatever the first sign is. If it was a minus, they'd both be minus. But since they're pluses. This one says they're both the same. They're both, in this case, they're both pluses. Third step. Take the first number and multiply it by the last number. 12 times 3 is 36. This is A times C. We have to figure out what two numbers multiply to give you 36. Since that's a plus, when you add them, you get 13. So what two numbers multiplied together give you 36? We know 1 times 36. Since it's an even, 2 times 18. 3 times 12. 4 times 9. 6 times 6. And that's it. Yeah, 4 times 9 is 36. When we add them, 4 plus 9 is 13. So it's 9 times 4, 9 plus 4. So we know that 9 and 4 go in here. Then the next step, remember, since there's an equal sign, we have to solve them. Very good. Set them both equal 0. Actually, not yet. We have to do something first. We can solve it here if you want, but it may give us an ugly answer. But I'll show you that both ways work. Let's go ahead and solve these, and I'll show you the other way we could have done it. So we've solved for x. So 12x, we have to move the 9 over, equals -9. Divide both sides by 12. So x is equal to -9 over 12. Same thing on the other side. Move the 4 over and divide by 12. And then simplify. What do 9 and 12 have in common? Yeah, 9 is made up of 3 times 3, 3 times 4. So they both have a 3 in common. So it's 3 over 4. Same thing with 4 and 12. 4 is made up of 1 times 4. 12 is made up of 3 times 4. The 4's cancel. So x is equal to -1 over 3. So it works, but it tests your knowledge of division. That's how come what we were supposed to have done here you're supposed to have factored out what they have in common first. What do 12 and 9 have in common? They both have a 3 in common. So I divide both of these by a 3. 12 divided by 3 is 4. 9 divided by 3 is 3. What do 12 and 4 have in common? They both have a 4 in common. So divide both of those. 12 divided by 4 is 3. 4 divided by 4 is 1. Get rid of those. Now it's a lot easier. We don't have to worry about canceling stuff out. Move the 3 over, divide by 4. Move the 1 over, divide by 3. They both give you the same answer, but the second method that we're supposed to have done gives us, it's much easier to do it that way. So this finds us our x-intercepts. Remember, we want to graph these things. To graph a quadratic equation, you need certain information. The x-intercepts. These are also called solutions. They're also called the zeros. The reason they're called zeros because if I put them back in the equation, it makes it equal 0. So x-intercept, solutions, and zeros all mean the same thing. Okay, we have the x-intercepts. We plot those. We need something called the vertex. What is a vertex? The highest or lowest point. It's the highest or lowest point on a curve. So it's the highest point if the graph looks like this. It's the highest point there. It's the lowest point if our graph looks like this. If it's the highest point, it's called the what? Starts with M. Very good. Maximum. And if it's the lowest, very good. The minimum. And we can tell which ones we have before we do anything. Remember, our quadratic equation looks like this. Ax squared plus bx plus c is equal to 0. Before we do anything, you can tell me whether you have a maximum or a minimum by looking at the A. If A is negative, the graph opens down and you have a maximum. If A is positive, the graph opens up and you have a minimum. You can tell me what you have, but just can't tell me where it's at yet. And another thing we need to know the y-intercept. Because once we find the y-intercept, we can find its symmetric point on the other side of the graph. Because remember, the graph is symmetric. This is what the graph looks like of x squared. This is the vertex. It has a X and a Y point. In this case, it's 0, 0. That's the vertex in this example. So if I went to -3 and it equaled 9, in other words, if I had a point there, can you tell me another point? There should be another point that's exactly the same on the other side. So it's going to be at +3, 9. Because it's symmetric about this axis. So if I give you one point, you can always tell me another point on the other side. This line here that goes through the vertex is called the axis of symmetry. It's the vertical line that cuts the graph of a quadratic equation into two equal halves. Remember from chapter 1, if it's a vertical line, what's the equation of a vertical line? X. So in this case, the axis of symmetry is X equals 0. So basically, the axis of symmetry is the X value of the vertex. That's the axis of symmetry. Now, how do we find the vertex? To find the vertex, we have two methods. One is by using a method called complete the square. When we do that, we put it into this form. The vertex method, because the vertex is the H and K values. Like the center of the circle we had earlier. H and K was a center. We do the same way here. It's the vertex of our parabola. But we have to learn this method. We'll do that next. Or there's a simpler way. We can use this formula. -b over 2a. That's the X value. Once we find the X value, the axis of symmetry, remember this is the axis of symmetry, we take that number and plug it back into our equation, and that finds our Y value of the vertex. Well, let me give you some, let's find the vertex. I'll give you two equations real quick. We'll look at the vertex with this method. Got those here. Find me tell me the vertex and tell me whether it's a maximum or a minimum. Remember what the equation looks like? Where's the vertex? Remember, here's the formula. The vertex is HK. As we said in chapter 1 and in chapter 2, if it's inside the parentheses, it's the opposite. So the vertex, since it's a negative 1/4, it's a positive 1/4. And the outside, it is what it is. So that's the vertex. Is it the maximum or minimum? Why do you say minimum? Because remember I said earlier, if A is positive, where's that? Where are our notes there? If A is positive, it opens up. If A is negative, it opens down. The coefficient of the parenthesis here is our A value. So since A is positive, it opens up. So it's like this. So we have a minimum. Let's look at another one. What's the vertex? And do we have a maximum or minimum? So what's the vertex? Negative, because it's always the opposite inside the parentheses, and it is outside. It's negative 5, 7. That's the vertex. A is negative 3, so we have a right. So our graph looks like this and like this. Now, both of the methods that we have, the standard form and the vertex form, they both have their pros and cons. Because now we know what's the axis of symmetry in this first one? 1/4. And the second is negative 5. It's a vertical line there. How would you find the y-intercept of the second one? What's the y-intercept of the second one? Nope. I know. And that's the problem with this one. How do we find the y-intercept? In chapter 1. We find the y-intercept by setting x equal to 0. So if we set x equal to 0, we got negative 3, 0 plus 5 squared plus 7. We have to work this out. 0 plus 5 is 5 squared. 5 squared is 25. 25 and positive times negative is negative. 25 times 3 is 75. Negative 75 plus 75 is bigger, so the answer is negative. 75 minus 7 is negative 68. So that's the y-intercept at negative 68 on the y-axis. So if you have the vertex form, you have to set x equal to 0 and work it out. If you have the standard form, the ax squared plus bx, just look at the constant. But to find the vertex in the standard form, we have to do some work. Let me give you this one. So what's the vertex of this one? Nope. To find the vertex, you have to use this formula. We have to label A, B, and C. Really just A and B because that's all they have in the function. What is A? Nope. Remember, the equation looks like this. Ax squared plus bx plus c. A, B, and C are numbers, not letters. The x squares and x stay there. They're the coefficients. So what's the coefficient of x squared? 1. B is the coefficient of x, which is 10. There are no letters in there. So we have to first find the x value. So the x value is negative b over 2a, which is also the axis of symmetry, which is negative 10 over 2 times 1, which is negative 10 over 2, which is negative 5. So the x value is negative 5. What's the y value? To find the y value, remember, look at the formula. We have to put this answer inside the original equation, and that'll give us the y value. So we have to go through f of negative 5. So anywhere I see an x, put a negative 5. Negative 5 squared is positive 25. Positive times negative is negative. 10 times 5 is 50. Plus 23. We can add these two, the two positive ones together. So 25 plus 23 is 48. Minus 50. 50 is bigger, so it's negative. 50 minus 48 is 2. Pretty good so far? That's just finding the vertex. Remember, to graph that, okay, we have a point. Is it the maximum or minimum? Remember, to find that, we look at A. Is it positive or negative? Positive, it opens up. It looks like this. So we have a minimum. Again, we could do a lot of this stuff without doing any math. We can tell you the basic shape of it, and direction, and all sorts of stuff. So we have the vertex. We have the y-intercept. We need points. So this leads us into the next topic. Find the x-intercepts. Solve this equation. I'll save you the time. It's not factorable. What times what is 23? When you add them, you get 10. 23 is a prime number. It's 1 in 23, so nothing. So we can't factor. We have to use another method. If we can't factor the function, then we need another method. And I'm going to show you two of them. Complete the square and the quadratic formula. So we'll use this one as the example. So this one's going to be called complete the square. X squared plus 10x plus 23. And here are the steps. You have to make sure that the leading coefficient is 1. If not, then divide each term by A. Remember, all of these, we have to have our equation set equal to 0. That's because it's an equation set equal to 0. So we have x squared plus 10x plus 23 equals 0. Check, check. Second step. Move the constant term to the other side of the equal sign. So we subtract 23 from both sides. What we want is this. We want all the x's on one side and non-x's on the other side. That's what we want. It'll make life much easier for us. Now comes the process. Add b over 2 squared to both sides. Remember, what is b? Where do we find b? B is the coefficient of the x term. So it's whatever is in front of the x is our b. In this case, it's 10. Just the number. If it's negative, don't worry about it. It's just the number. So we're going to add 10 over 2 squared to both sides. The reason it doesn't matter about the signs is because when you square it, it's going to be positive anyway. On the left side, only do inside the parentheses. The right side, work it out all the way. So on the left side, we just have 10 divided by 2 is 5 squared. Leave it that way. Now, on the right-hand side, we work it out because we only want one number here on the right-hand side. So we have negative 23 plus 5 squared. Negative 23 plus 25 equals 2. Now, step 5 is where we're actually complete the square. This is where we're actually going to do the complete the square. On the left side, take what is under the exponents and the first sign, place them inside parentheses squared. So take whatever's under the exponents and the first sign and put them inside here. So what this is saying, this number, and this sign. If we were looking for the vertex, all I would have to do here is set it equal to 0. In other words, move the constant term to the other side. If I move the 2 over here, now I have the vertex form. The vertex is at -5, -2. Okay, so, but I want to know what the x-intercepts are. That's where I'm gonna go here. Now we have to solve for x. Square root both sides, because we're trying to get x by itself now. We have to get x by itself, so we have to get rid of the square. Square root both sides. Okay, here's something important. Whenever you take the square root of something that's squared, you have to put a plus or minus on the other side. The reason being because if I square a number, -2 times -2 is +4. +2 times +2 is 4. So whenever I square root something that's squared, always put a plus or minus in front of the answer. So those cancel. So I have no, and last step is solve. Solve for x. So square root both sides. Place plus or minus in front of the answer. So we have x plus 5 equals plus or minus square root of 2. When we solve for x, just subtract 5 from both sides. So x is equal to, these are our two answers. How do we get two answers? It's negative 5 plus square root of 2, negative 5 minus square root of 2. Those are our two x-intercepts. Again, it's a whole process. Do that again. Then I'm gonna show you a shortcut. We'll do this one pretty quick. I'll do a fraction one. Find me the solutions. Well, first off, is this going to be, do we have a maximum minimum for a vertex? Just look at sign in front of x squared. Is it positive or negative? It's positive, so it opens up. We have minimum. So is our A term 1? No. X squared over 2 is actually 1/2 times x squared. When we do this, x squared has to be by itself. So how do we get rid of the 2? Well, we set equal to 0. How do we get rid of the 2? Multiply. Multiply every term by 2 on both sides. So the 2's cancel here. So we have x squared minus 8x plus 16. Remember, all the x's on one side. So we have x squared minus 8x equals negative 16. We have to move the 16 over. Then what do we do? We have to add b over 2 squared to both sides. Add b over 2 squared to both sides. On the left-hand side, just do what's inside the parentheses. On the right-hand side, work it all the way out. So we have negative 16. 8 divided by 2 is 4 squared. So this equals 0. Whatever's under the square, the first sign, whatever's under the square. Square root both sides to get rid of the square. Put a plus or minus in front of the answer. But the square root of 0 is 0. The square root and square cancel. So x is equal to 4. That's our x-intercept. We know the graph opens up. We know our x-intercept is 4. So that means our graph will look like this. Since we only have one x-intercept, that's the only place it's touching. It's a process you have to learn how to use. It takes practice. But heads up, it helps if b is an even integer. If it's an odd integer, we're going to have fractions. And that sucks. We'll do one of those next time. But I want to show you the last one, quadratic formula, which always works and it's easiest. The last method is a quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Okay. If you're given the equation like this, we define our label A, B, and C and plug them in there. And work it out. So let's look at the one we had earlier. We want to find the x-intercepts. So we label A, B, C. What is A? 1. B and C. Plug them in there. Negative b plus minus b squared. So here we have negative b is 10. Plus or minus b is 10. 4 times a times c over 2 times a. Now you see why the beauty of the quadratic formula. All it is once you plug it in there, just math. Do inside the square root first. 10 squared is 100. 10 times 10. Positive, negative times positive is negative. 4 times 1 is 4. 23 times 4 is 92 over 2. $100 minus 92 is 8. We can see if we can fix inside the square root. 8 is made up of 2 times 4. 4 is 2 times 2. So the square root of 8 is the square root of 2 times 2 times 2. Since it's a square root, if we have 2 of a kind, they can come out. That leaves a less extra 2 inside there. We have 2 radical 2 over 2. Can anything factor out? Do we have anything the same on the top? They both have a 2. Remember, when we factor anything out, just divide by them. 10 divided by 2 is 5. It's negative 5. That's negative. Twos cancel, so we have square root of 2. And that's what we got last time. So there you have it. It's all works out that way. We know we figured out how to find the vertex. We have the x-intercepts. We know if it opens up or down. We can now draw a graph. Just find one more extra point, and it's got a mirror image. Okay. That's it for that section. Okie doke. So have a great weekend. And I